So here we have a application to the derivative. It says find the equation of the line tangent to the graph of y equals x squared plus 2x plus 4 at a certain point at 0, 4. So tangent of the line tangent to the graph means we want to find that derivative, and then we want to do some work from there. So let's just start off with that. Let's get the derivative. So y prime derivative using the power rule, x squared becomes 2x. Because this is 2 times 1 is 2, minus 1, 2 minus 1 is 1, so just 2x. And then here, 2x to the first, so 1 times 2 is 2, and then x to the 1 minus 1, 1 minus 1 is 0, so we get x to the 0, anything to the 0 power is 1, so we just get 2x plus 2, and then we have a constant here. Derivative of a constant is always 0, so the derivative of 4 is going to be 0, so I just have the derivative is 2x plus 2. Now, we want to come up with an equation of the line tangent to the graph here. So this line represents the line tangent to the graph, the slope, or the derivative. Now we want to get the slope at a certain value of that x value. So we're going to do f prime of 0. And have 2 times 0 plus 2. Because what we want to know is we want to know what is the slope at the x value of 0. So for example, let me draw this off to the side real quick. So if I had the graph, x squared plus 2x plus 4 would be somewhere over here roughly. X squared plus 2x plus 4. And we are wondering what is the equation of the line tangent to the graph at the point 0, 4. So let's call this point 0, 4 right here. So we're going to have a line tangent right there at 0, 4, and we want to know that equation. So we are determining the slope at x equal to 0 using the derivative, and then from there we'll get slope, and then we'll be able to use point slope because we'll have slope, we'll have an x value, we'll have a y value, then we should be good to use point slope. So that's what we're doing right now. That's the thought process. We're determining slope at this point of x equal to 0. And then that will help us generate our equation. So f prime of 0 is 2 times 0 is 0, plus 2 is 2. So I have slope, I have an x value, I have a y value, so now we're going to use point slope. So y minus the y value of 4 equals the slope. So y minus y1 equals the slope, which is 2. X minus the x1. So it's using point slope here in order to come up with the equation of the line tangent to the graph. So to solve this, we have y minus 4 equals 2 times x is 2x. 2 times 0 is 0, so I'm just going to leave that as 2x. Add the 4 over. So we get y equals 2x plus 4. So that is the equation of the line tangent to this graph at 0, 4. Good application, good understanding of the derivative and the relationship of the derivative and the tangent line and everything, and to come up with this equation at a specific point. Now if we ask a different point, that equation would be a little bit different because that tangent line is going to travel around the function. Like if I wanted to get it at another point, like here, my line would be something like that. Like if I wanted to try to get the tangent line equation from that point. Another common example that you would see in these types of applications is it might say something like a horizontal tangent. So it might ask, there's two main scenarios that we'll look at when we're looking at finding the equation of the line tangent to graphs. You're going to look at specific points like we did here, and then you're going to look at horizontal tangents. What does horizontal tangent mean? Well, horizontal tangent means the tangent line is horizontal. What is the slope of a horizontal line? The slope is 0. So the derivative, so you'd set the derivative equal to 0 because you'd want the x values that would determine when that derivative is equal to 0. So you get your derivative, and then you set that equal to 0. So there's a little bit of a different layout for a problem like that. But those are pretty much the two big scenarios that you'd see. At a certain point, and when you want a horizontal tangent.